In the last class, we had discussed about connecting resistors in series, and in this class, we are going to discuss about connecting resistors in parallel. And we must always remember that when we connect in parallel, actually we are connecting each resistance to the potential difference source. So if we have a number of resistors, say like this, the first one, then this, the second one, and another one, say third one, then each of these are connected to the source such that the potential difference supplied by the source is received by each of the individual resistors. Hence, what we have is, if the potential difference of this source is V, then each of these resistors will have potential difference V across themselves. So this resistor R1 is having potential difference V, this resistor R2 is also having potential difference V, and this resistor R3 is also having potential difference V. However, the current that is coming out from here is actually getting divided. So the current, total current I that is coming out from here is getting divided, and the current passing through R3, let us call it I3, and the current passing through R2, let us call it I2, and the current passing through R1, we shall call it I1. Obviously, the current I1 will be equal to V divided by R1, because that follows from Ohm's law. Similarly, the current I2 will be equal to V divided by R2, and the current I3 will be similarly equal to V divided by R3. Now we can easily understand that all these three currents, I1, I2 and I3, if they are added up, the sum of these three will give us the total current I that is flowing out from here. So we have I equal to I1 plus I2 plus I3. Now that again flows from that law of conservation of charge, because this is I1, actually this is I1, this is I2 and I3. So now this follows from law of conservation of charge, which says that charges can neither be created nor destroyed. All the charges that are coming out from this have to return back to here. So if the charges coming out from here are getting distributed like this, from here, and from here, and then all those charges will combine up once again to get that sum total which had come out from here. So hence we have this relation I is equal to I1 plus I2 plus I3, and this I, according to Ohm's law, will be V divided by R, where R is actually the net resistance or the resistance of the resistor, which is equivalent to the net resistance of all the three resistors over here. That is, if instead of these three resistors we use a single resistor, then that resistor will have an effect equal to the combined effect of all these three resistors. That resistor has resistance equal to R. So here I will be equal to V by R, and V by R will be equal to I1 is V by R1, and similarly the others also. I2 will be V by R2, and of course I3 will be equal to V by R3. Now we have V common on both the sides, so we can just simply cancel out them, and what we get finally is 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now that is there for three resistors. If we have many resistors, then we can just continue doing that, and we shall have R1 plus R1 plus 1 by R1 plus 1 by R2 plus 1 by R3, and so on so forth. So we have say let us call this 3. So we have 1 by R1 plus 1 by R2 plus 1 by R3, and if we have n resistors, then we'll have 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus dot 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 up to 1 by Rn. So we have n resistors, and then we can find out the resistance, the combined resistance of n resistors connected in parallel in using this relation. We can take up a quick example over here. Suppose we have these three resistors with values R1 equal to 2 ohm and R2 equal to say 1 ohm and R3 equal to say 3 ohm. So what is the net resistance of this combination of resistors? We can just use this expression over here, and we can say that 1 by R will be equal to 1 by R2, that is 1 by R1, that is 1 by 2, plus 1 by 1, and finally 1 by 3. So we can just take up the common denominator from these things, and that will be 6. I'll just solve it over here, running out of space. So it will be 6, and we will have 3 plus 6 plus 2. I'm extremely sorry because we are running out of space. 9 plus 2 is 11, and it will be 11 by 6. Now mind this, that this 11 by 6 is actually 1 by R. Okay, so if we have to calculate R, we have to invert this. So since 1 by R is equal to 11 by 6, we shall have R equal to 6 by 11 ohm. So that is how you calculate the net combination of resistors when connected in parallel. The expression is over here, and we shall take a break now and come back very soon for more such interesting topics. Thank you.